Scheme is a language for symbolic programming, which is a fancy way of saying that it's not just about numbers. So in the early history of computing, it was all computers were all about numbers. It started out being scientists doing, whatever it is they do, physical modeling, and a lot of soldiers figuring out how to blow things up numerically. And then businesses came along and started cranking out their payroll checks, doing budget projections and so on. So it was all numbers in the early days of computing. And then people wanted to be able to compute about ideas. And this is something that came out of the artificial intelligence research community. They wanted to get computers to do things that are sort of like things people do. And they thought one way to do that was to get a handle on ideas in the computer program. And that meant basically words and hooking them together in different ways. So we can do that too. But if I just type in a word here, what I get is an error message. And the reason for that is when I typed in the plus sign a while ago, I didn't get back plus sign. Right? I got back the addition procedure. So numbers are their own answers. You say 5, Scheme says 5 back. But that's not true for data other than numbers. So the value of plus sign is the addition procedure. The value of the word hello, there isn't one. And that's why I got this error message. When you get an error message, don't panic. That's a mistake some students make. But also don't ignore it. Actually look to see what the error is. And you have to look up here. After the line that says asterisk, 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 error, it tells you what the error was. Namely, unbound variable hello, which is a fancy way of saying that the name hello isn't associated with a value. I could fix that. Whoops. Thank you. I could fix that by saying define hello to be 8. And now if I say hello, I'll get 8 back. OK? Well, but what if the value that I want is the word hello? I don't want whatever the value of the variable is. I want HELLO. What I have to do is quote it. This character that I just typed, I don't know if the resolution is good enough for you to see. It's not what you think of as a quotation mark. It's what you think of as an apostrophe. We refer to those as single quote and double quote. This is a single quote. Hello. They don't come in pairs. It's just single quote and a word. And the value of that is the word. Notice that the value is not quote hello. So I'm going to gain you a point on midterm 1 by reminding you that you're not going to see quotation marks in values. Quotation marks are part of things you type. So when we say, what will Scheme print as a result of blah, 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 don't say quote hello, because that's wrong. It will be hello. OK, that's words. We can do functions of words. So first is a function that takes a word as input, and it gives you back the first letter of the word. But first, it doesn't mean, turning around. It means all but the first letter. So ELLO in this case. And we can do compositions of functions. So I can say first of, but first has an abbreviation, BF. Quote, hello. What's the answer going to be? E, right. OK, so that's how you find the second letter. There's also last and but last that do the obvious thing. We can do composition of functions, as you saw. Numbers are words. Every once in a while, that'll come in handy. So I can say, what's first of 473, and get back 4. or but first and get back 73. Okay. So So here's how I give something a name. I say define, name, and then an expression producing the value. In this case, the expression is just a number. And this define is the first exception we're going to see to the usual rule of how Scheme does things. Remember I told you that Scheme evaluates expressions from the inside out. So if define were like an ordinary procedure, then the very first thing this expression would have done is try to find the value of the symbol pi. And there wouldn't have been any value because I hadn't done the define yet. And so I would have gotten an error message, unbound variable pi. Define is a special case. There's a funny name for special cases. They're called special forms. So loosely speaking, define is a special form. Actually, that's not quite right. Define pi 3.14, et cetera, is the special form. Define, which is kind of the name of the special form, is called a keyword. But practically everybody says define is a special form all the time, and you're supposed to just understand what they mean. And what's special about it is that it doesn't evaluate that first input, because that's always just a symbol, a word, that you want to give a value to, and it uses the unevaluated name. It does evaluate the second input. If I say define foo to be plus 2, 3, oops, the value of foo is not plus 2, 3, it's 5. Okay? Once I've defined a name like pi, I can use it not just by typing it by itself, but in expressions. I can say what's times pi pi, and the answer is a little less than 10. Things like that. Okay. I can also define things to be procedures, and the notation for that is a little bit different. So I'm going to say define second would to be first of but first of would. So now I can say second, quote, help, and get E. Okay, so in that definition, the thing right after define is supposed to look like what a call to this function is going to look like. Namely, open paren, the name of the function, and then some number of inputs. And for each input, what I give it here is a name for the input to use inside the procedure. So internal to this procedure, WD means whatever the input is to second. And the way this can be evaluated, this is what the book calls the substitution model of evaluation, is that we take whatever the actual argument is in the call, like in this case it was, quote, help, and just stick that in wherever you see WD in the body. So we come up here. Here's the body of the procedure, the thing that I actually want to calculate. It's an expression. And so we make this first of but first of, quote, help, just sticking the argument in place of that name, and then evaluate that. Okay? Define square x to be times xx square 7, 49. Okay? Okay. Right. So time for a little vocabulary lesson. I've been using the name input for things you give procedures. And that's kind of loose talk. And so I might say that the input to square is x, or I might say that the input to square is 7. But we actually have names for those things. So when you're defining a procedure, that's called a formal parameter. That's a fancy name for the name of the input inside the procedure. And then I say something like square of plus 2, 3. This thing is an actual argument expression. And then there's one more thing, which is the actual argument value, which is 5. It's not in that interaction at all, but it's the value of plus 2, 3. Okay, so what Scheme does when you make a procedure call, it evaluates the actual argument expressions, however many there are. And having done that, it comes up with a bunch of actual argument values. And then it substitutes those values for the formal parameters wherever they occur in the body. So in this case, we get times 5, 5. The value of that is 25, which I hope is what, oh, well, I said square 7 up here and got 49. Let me just go and do square plus 2, 3, just so you'll believe me that it works. OK? So most of the time, either it doesn't matter which of these things we're talking about, or it's clear from the context which of these things we're talking about. And so people will just say argument to mean any one of those three things, being lazy. When it matters, when I'm trying to make a point about the differences and which one we're talking about really, I will use the official name. Sometimes you just hear parameter instead of formal parameter. They mean the same thing. Sometimes I'll just say actual argument, and that means, well, whatever you type in its value, you know, thought about in the right way for how Scheme evaluates things. But these are the three names for when you really want to get it right.